video we are going to discuss another problem from Bmath 2008. So it's basically the seventh problem, which says that if you have points I comma j and where I and j are both varying from 0 to 24, and so this is the set, and so basically these are called the lattice points, and these points and you are restricted to these points. So how many squares can be formed in the plane, all of whose vertices are in that set C and whose sides are parallel to the x-axis and the y-axis? Okay, so this is nothing about coordinate geometry or something. So it's basically in an n cross n square. If you know how many squares are there, that is parallel to the sides of the main square, the bigger one, n cross n. So that's the problem. So let's solve it. Okay, so here we have okay, so now so this is the x-axis and this is the y-axis as usual, and now what you are trying to do is you are basically trying to form these squares. Okay, so I'm just using this board. So for the last 2 days, so that's why maybe I'm having some problem. Okay, so this is the condition. Now notice that how many squares will be there. Okay, so how many unit squares will be there? So there would be, so this is 0, this is 1, this is 1, this is 2, this is 3, this is 2, 3, and so on. Suppose till the last one, 24. Now, so this is suppose 23 and this is 24. Now what? Now you see that there would be in total 24 squares, like 24 squares. Okay, unit squares, I mean small. So if you just think that those are the only squares, then you are very wrong. There can be squares of length 2 cross 2 like this. Okay, there can be squares of length 3 cross 3, 4 cross 4 till 24 cross 24, which is the whole square. So there is only one square of dimension 24 cross 24. Okay, so now if we just try to list down, so for 1 cross 1 we can easily calculate how many are there. That is 24 cross 24. So 24 square. Now for 2 cross 2, how many will be there? So that is basically, you have to understand that when you are getting a square which is of 2 cross 2 dimension, then it corresponds to a side of length 2 on the x-axis and a side of length 2 on the y-axis. Okay, so if you have a square, it corresponds to these two sides, and if you take any two sides like of length 2 on the x-axis as well as on the y-axis, so that will also form a square of length of dimension 2 cross 2. So that is basically a bijection between the number of squares of length 2 cross 2 and the number of ways you can select sides of length 2 on either side. Okay, so now the counting the number of 2 cross 2 squares basically boil down to the number of ways I can select length 2 on the x-axis and the y-axis. So the number of such pairs. So first let's concentrate on the x-axis. So it would be very, very much similar on the y-axis. Absolutely the same on the y-axis. Why? Because here also you are going from 0 to 24 on the x-axis, and on the y-axis you are also going from 0 to 24. So now you see that what you are now trying to do, you are now trying to figure out how many length 2 sides are there on the x-axis from 0 to 24. Okay, so if you want to select two consecutive sides basically, so that means one example is like you are selecting from 0 to 1 and then 1 to 2. Okay, then you are selecting from 1 to 2, 2 to 3. Okay, and so on and so forth. So this is the first one, and then this is the second one, and so on and so forth. You can continue like this, and now try to understand. You can start from 22 and the last one would be that. So starting from 22, okay, 22 to 23 and 23 to 24. So now what happened is that we started from 0, so first 0 to 2, then 1 to 3, and so on and so forth. So if you see the pattern, so it's basically you can select 23 such sides. Okay, why? Because from 0 to 2, then 1 to 3, so you're starting from 0. Okay, you are getting length of side 2. You are starting from 1, you're getting a length of side 2 till you are doing this till 22. So from 0 to 22. Okay, so that means 23 such sides you are getting, and so 23 such sides on the x-axis, and each side when combined with one of the 23 sides on the y-axis will give you a square of length 2 of dimension 2 cross 2. So we are having 23 squares, okay, of dimension 2 cross 2. For similarly for 3 cross 3, again if you notice that you are selecting 3 consecutive sides on either side, on the x-axis and on the y-axis, and so what you are getting is you are starting from 0 and then you are going till 3, and then you can do you can go on, and the last one you can start from 21. Okay, so from 0 to 21, for each number you can start and you can get a side of length 3. So that means you are getting 24 such sides of length 3. So 22 sides of length 3, and again on the x-axis you're getting 22 such sides of length 3, and similarly on the y-axis also 22 sides of length 3, and you just pick up any one from the y-axis part and any one from the x-axis part, just combine them, they would give you a square, okay, of dimension 3 cross 3, so 22 square, and so on. So you now got the pattern. So basically for 4 cross 4 it would be 21 square, okay, and so on till 24 cross 24. That's the largest dimension that is possible, and you can very well understand that's the whole thing, so only one, so that is 1 square, okay. And these are all the possibilities, 4 cross 4, then 5 cross 5, because you are going to figure out squares, not rectangles or something else. So they would be of the form n cross n, and so if you sum them up, then what you're basically getting is, so the sum is 1 square plus 2 square, okay, sorry, so let me okay, yeah, so the sum is 1 square plus 2 square plus 3 square plus ... till 24 square, okay. So here, so as you know that there is a formula for sum of the squares of the natural numbers from 1 to n, so that is 1 square plus 2 square plus ... till n square is n times n plus 1 times 2n plus 1 divided by 6. So if you still don't know this formula, you can, so I told you here, now why would you accept just like that? So you can verify that, you can prove it by the use of induction, okay, just induct on n and prove it. And so this sum would be basically then, this is n is 24 in our case, so 24 times 25 times 2 times 24 plus 1, 49 divided by 6, okay. Yeah, so I calculated this somewhere, so yeah, it's 4900, okay. So that's the answer. So that is not important, so the main thing is the concept behind it, okay. So that's the concept. Now for if you want to generalize this, then what happens is for any n cross n, so this was a 24 cross 24, so for any n cross n, suppose they can say that for any n cross n chessboard or whatever, so the number of squares in it would be 1 square plus 2 square plus ... till n square, okay, and which is nothing but n into n plus 1 times 2n plus 1 divided by 6, okay. Now if you have got how to figure out the number of squares, then try it out for rectangles. So the for the rectangles, the difficulty would be like you are having here only the dimensions which are of the form like n cross n, but in rectangle it will be of dimension m cross n. So yeah, I of course mean all those rectangles whose one of the side whose both sides are basically parallel to either the x-axis or the y-axis, okay. So yeah, so even the squares would be considered into the rectangles, because a square is a rectangle, okay. So now the answer would be larger than this, of course, as the number of squares also is counted there, okay. but along with them you're calculating the number of rectangles. So think about it. Okay, so that's it for this video. We'll meet in the next one. Thank you for watching.